In the area of science and gigantic mysteries pertaining to what was previously before the gigantic explosion, there have been blended conversations and intrigued characters for quite some time. This enormous question tests more than just our ability to decipher the universe, it challenges the genuine furthest limits of human knowledge. Imagining yourself at the brink of existence while examining the colossus, observing and pondering the contents that existed before our universe was imagined. The Big Bang, which established the beginning of time, space, and all that we know, were you there a moment earlier? Was there previously a condition of nothingness, a calm before the cosmic gathering began? And if this is true, was it? Or perhaps was there something much more alarming that existed before the beginning of time? As we continue with this inquiry, science takes us on a journey past the universe's beginning point into thoughts that test our conscious awareness. Physicist Brian Cox, known for his investigation into the awe-inspiring universe, suggests that something surprising may have existed prior to the enormous detonation. He urges us to reconsider our concept of reality and existence. In this examination, we'll dissect the science, the speculation, and the dazzling insider secrets that might make sense of what existed preceding all that we know. We will investigate ideas like self-important development, quantum changes, dark energy, and even multiverse. The answers we've revealed might just paralyze you, yet they could likewise open new understandings of our position. Prepare to plunge into the depths of the universe, into a world beyond imagination and science, where the obscure still wins around the shadows, leaving scientists shocked, and sometimes even upset. We ought to explore what existed before the Big Bang, and why these theories test everything we thought we knew. To appreciate what may have existed before the Big Bang, we first need to painstakingly analyze what the Big Bang truly was. The Big Bang, as scientists define it, means the point in time when the universe became extremely dense and hot, rapidly expanding to cause the development of all matter, energy, and space. When we look at the night sky, we see proof of this hot beginning, with galaxies spreading out this way and that from an early stage point. However, why did this happen? Furthermore, was there a period before this thick, hot start? As indicated by the theory of enormous expansion, there was, without a doubt, a time before, and it was not even close to void or peaceful. Vast expansion suggests that before the Big Bang, the universe was in a state that was cold, vacant, and loose, essentially like an immense vacuum. Nonetheless, this vacuum was not entirely unfulfilled. It contained a tremendous amount of energy that fueled the quick extension of space itself. This extension, called inflation, occurred so quickly that it essentially established the groundwork for all that would follow, a part of a later space that extends at unfathomable rates until the extension slowed down, and the energy changed into particles of matter and the forces we observe as the Big Bang. But what kind of energy was it? Why did it suddenly grow the universe, and why did it stop? Experts believe that this immense expansion resulted in patches of the universe, each with its own Big Bang. Imagine a fabric extending endlessly with tiny pockets of air forming here and there, each air pocket representing a universe, including our own. This thought, called the inflationary multiverse, suggests that there are possibly limitless Big Bangs and an infinite number of universes. Our own is just one of many. This huge, mind-bending reality challenges our perception of the entire universe, leaving us with the question, what else is out there? The idea of nothingness before the Big Bang is speculative, not real, at any rate, based on what we currently know. Regardless of whether you eliminate all energy, particles, and radiation from the universe, it still wouldn't be genuine void. Our universe is filled with dark matter, quantum fields, and dark energy. Other forces that weave an inevitable tapestry of something, even in its most vacant form. Regardless of whether we imagine stripping away all of these forces, leaving a dead space, the universe would still generate new kinds of energy. This reality alone is bewildering to specialists, as it suggests that actual inertia could be impossible in our infinite universe. Comprehension of space itself has properties, rules, and constants that prevent it from being totally empty. Imagine creating a region with literally no particles, no radiation, and no energy, except quantum fields and important constants. These would continue to exist, suggesting that this nothingness has properties. For example, there is a peculiarity called zero-point energy, which represents the least amount of energy possible, the ground state of quantum fields. In this state, particles can still momentarily appear and vanish, creating an unsettling resonance of movement even in what should be empty space. This challenges our idea of a real void and suggests that, yes, even before the Big Bang, there was a phenomenon that only scientists are beginning to understand. One of the most astounding theories in current cosmology is the chance of timeless expansion. If inflation could cause our universe to exist, it's possible it could continue forever. Brian Cox describes an astonishingly vast inflationary multiverse, where universes are infinitely created and continue expanding. Imagine each Big Bang as a flash lighting another universe, while inflation continues in different areas that create numerous other universes. This cycle could, in theory, go on for eternity. This idea of vast universes gives birth to an enchanting concept of a fractal universe, where each new universe may actually develop its own Big Bang. Every universe exists as a separate, independent domain that is not affected by others because of the rapid expansion of space. For researchers, this hypothesis is both exciting and upsetting, as it suggests a never-ending multiverse with no predetermined beginning or end, our universe being just one bit in a giant cosmic structure, forever expanding and constantly creating new universes. And what if the disturbing reality is that there is no before or after, but rather a timeless pattern of universes evolving in the same way that we do? Our interpretation of nothingness changes when we consider quantum field theory. The universe, in this theory's view, is not just an assortment of matter floating in space. Rather, it's a complex network of energy fields that fill the universe, connecting to create all that we observe. These fields are like invisible seas, with particles acting as waves or disturbances. Even when fields are at their known lowest level of energy, as the vacuum state, they are still alive. Particles can appear and disappear in these fields, momentarily acquiring energy before returning it. This phenomenon results in virtual particles, substances that immediately exist and then vanish, leaving only a faint memory of their presence. The concept of virtual particles casts doubt on the notion of a real void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have total nothingness? According to quantum field theory, you wouldn't. Even in a vacuum, fields would remain active, sometimes creating transient particles. This constant movement in what should be nothing suggests that the developments in modern cosmology. If these ancient gravitational waves are detected, they could act like fingerprints left behind by the cosmos, carrying information about processes that occurred before or during the Big Bang. Scientists have already detected gravitational waves from colliding black holes and neutron stars, but the elusive primordial gravitational waves, those that originated in the first moments of the universe, remain hidden. If found, they would serve as a direct probe into the pre-Big Bang environment, offering evidence of inflation, cosmic phase transitions, or even other universes brushing against ours. These ripples might confirm the presence of quantum fluctuations that were stretched during inflation, laying the groundwork for the structure of our current universe. But what if we go further? Some speculative models suggest these gravitational waves could even carry signatures from a previous universe, supporting the cyclic model or indicating quantum tunneling from a higher dimensional realm, ideas that seem ripped from science fiction but are actively being explored by theoretical physicists. Another captivating perspective comes from loop quantum cosmology, a branch of theoretical physics that attempts to unite quantum mechanics with general relativity. It proposes that the Big Bang wasn't the beginning, but rather a big bounce. In this framework, the universe didn't emerge from nothing but rebounded from a previously collapsed state. Instead of an absolute beginning, we might be living in a universe that has expanded and contracted countless times, a cosmic heartbeat that defies linear history. Then there's the concept of emergent spacetime, a bold idea suggesting that space and time themselves are not fundamental but rather arise from deeper, more abstract quantum relationships, like entanglement among particles. If true, it means before the Big Bang is a meaningless concept in the conventional sense, because time itself did not exist. There was no before, only a raw quantum state, timeless, non-local, and entirely foreign to human perception. So where does that leave us? We are left with a universe brimming with paradoxes, a cosmos that may be infinite in both space and time, or perhaps neither. The further we peer into the fabric of reality, the more we realize that our questions about origins might be rooted in the wrong assumptions. The Big Bang may not be the beginning, but merely a threshold, a transition between unknown states of cosmic existence. And yet, even as science pushes these boundaries, one mystery remains untouched. Why is there something rather than nothing? This profound philosophical question haunts every scientific theory, lurking behind every equation and observation. Whether through multiverse, dark energy, quantum vacuums, or gravitational echoes, we are attempting to solve not just a scientific riddle but a cosmic enigma, one that may never fully yield its secrets. Possibilities in cosmology today. As it might not only reveal the truth about the Big Bang but also offer a glimpse of the cosmic state that lies before us, the universe was born. This theory offers a tantalizing prospect, detecting gravitational waves that could act as fingerprints of a pre-Big Bang universe. As we continue to explore what could have existed before the Big Bang, we investigate ideas that push the boundaries of our understanding, challenging even our most fundamental assumptions about space, time, and being alive. One of the most mind-boggling ideas comes from the realm of quantum gravity, a field that seeks to merge quantum mechanics with general relativity. This merger could potentially expose a single theory for everything and could provide insight into what existed prior to the quantum Big Bang. According to quantum gravity, time and space are not smooth, continuous entities as we experience them. Rather, they may remain hidden, granular structures. This theory posits that the space-time fabric itself could have been formed from a microscopic Planck-scale structure, with tiny quantum fluctuations shaping the universe in ways we cannot yet fully comprehend. In this view, what we perceive as the smooth continuum of space and time might have only emerged from these fluctuating quantum fields. Thus, before it was possible to describe the Big Bang, a radically different concept of reality may have existed, one where space and time themselves lacked completeness. Another possibility is that the universe is part of a vast cosmic landscape of possible universes, each with different physical laws and constants. This theory, known as the string landscape, arises from string theory, which suggests that all fundamental particles are actually tiny vibrating strings. In this framework, there are many possible configurations of these strings, each corresponding to a different set of physical laws. The string landscape could imply that our universe is just one of many, each emerging from its own distinct Big Bang, if such an event exists. The landscape also suggests the idea that other universes might have different strengths in different dimensions of gravity, or even different types of matter. In this view, our universe might not be unique, but rather a part of a multiverse, a collection of universes, each evolving independently. The multiverse theory provides a speculative yet intriguing response to the question of what came before the Big Bang, another universe, arranged in a different way, potentially leading to infinite cycles of creation and destruction, with no definitive origin. In addition to these cosmological models, some theoretical physicists have also considered the role of black holes in shaping the nature of the universe. A hypothesis gaining attention is that our universe could be the result of a black hole formed in another universe. In this scenario, the singularity at the center of a black hole could serve as a gateway to another universe. The Big Bang was the beginning of our universe, a moment when such a black hole gave birth to our cosmos. This hypothesis is bolstered by the fact that, as per general relativity, the singularity at the center of a black hole is a point where the spacetime curve is infinite, creating a region where the known laws of physics break down. It's possible that the extreme conditions inside black holes could lead to the creation of new universes, which may suggest that what we consider the Big Bang was just the birth of our universe from the singularity of an ancient black hole. Exploring these concepts requires a deep dive into the very nature of time itself. Some cosmologists speculate that time, as we recognize it, might not have meant anything before the Big Bang. If time began with the Big Bang, then there may have been no before in any conventional sense. According to this view, time itself might have emerged from a quantum fluctuation or from a primordial state where the common differences between past, present, and future did not apply. This could lead us to reconsider the idea of causality, which is predicated on the assumption that events happen in a linear sequence. If time did not exist as we know or experience it, then the question of what came before the Big Bang becomes absurd, because there wouldn't be any temporal framework to support it. Further complicating the picture are theories of cyclic time. As mentioned previously, cyclic cosmology posits that the universe goes through endless cycles of birth, development, and eventual demise. In this model, the Big Bang could represent merely the most recent swing in an eternal series of universe cycles. These cycles might not be the same, but they might evolve in different directions, each with unique physical properties. The cycle of the universe, according to this theory, would be an ongoing procedure without a true beginning or end, rendering the question of before the Big Bang in the conventional sense meaningless. The idea that time itself might be cyclical implies that each and every Big Bang could be followed by a contraction and another big crunch, with the universe reinitiating itself in an endless loop. Another avenue of investigation into the nature of the cosmos is the potential existence of a primordial liquid of bits and fields that existed before the formation of stars and galaxies. This idea suggests that prior to the universe beginning its rapid expansion, it was filled with a dense and hot mixture of elementary particles, including quarks, leptons, and bosons, all in a state of extreme energy. These particles would have been interacting at extreme temperatures and densities, laying the foundation for the formation of matter and energy. As the universe cooled, some versions of this theory suggest that this primordial soup existed in a quantum foam, where particles constantly emerged and vanished as a result of quantum uncertainty principles. The properties of this soup could potentially offer insights into the earliest moments of the universe, and, by extension, what preceded the Big Bang itself. Ultimately, what existed before the Big Bang remains one of the most profound mysteries in science. As our understanding of quantum mechanics, cosmology, and fundamental physics deepens, new theories will continue to emerge, offering increasingly complex and sometimes paradoxical explanations for the origins of our universe. While we may never fully grasp what came before the Big Bang, the pursuit of this knowledge will continue to stretch the limits of human curiosity, driving us to explore the unknown frontiers of existence. This relentless pursuit of understanding what came before the Big Bang not only challenges our scientific boundaries but also touches on philosophical and even metaphysical questions. At the heart of this inquiry lies a deeper contemplation. If the universe had a beginning, what initiated that beginning, and what lies beyond the scope of empirical observation? Some theories propose that the concept of nothingness itself needs to be redefined. In quantum mechanics, even what we perceive as empty space isn't truly empty, it teems with virtual particles popping in and out of existence. This suggests that what we once called nothing may, in fact, be a seething quantum vacuum rich with potential. From this vacuum, it is hypothesized, a fluctuation could have sparked the Big Bang, an event not out of nothing, but out of a different kind of existence entirely. Others argue that the Big Bang may be a local event, just one bubble among countless others in an infinite expanse of higher dimensional space. In the theory of eternal inflation, regions of space continue inflating endlessly, spawning pocket universes like our own. Each of these universes may have different properties, dimensions, and physical constants. From this perspective, our universe may be just a tiny piece of a vastly more complex and infinite multiversal tapestry. This also brings us to the holographic principle, a concept that suggests all the information contained within a volume of space might actually be encoded on its boundary. If this is true, the entire three-dimensional universe could be a projection from a two-dimensional reality. It's a mind-bending idea, one that raises further questions about what before even means in such a construct. Could the Big Bang itself be a mere projection, an effect of a more fundamental process occurring on a boundary beyond our perception? Time, space, matter, and energy, all pillars of our current understanding, may be emergent phenomena, arising from something more basic and abstract. Some physicists speculate that information, not particles or waves, might be the most fundamental building block of reality. In this view, the universe could be thought of as a vast computational system, unfolding according to underlying informational laws. In that case, the Big Bang might represent not the beginning of existence, but the initialization of a new informational process, a kind of cosmic program launch. If such ideas hold weight, what came before the Big Bang could have been a pre-informational phase, a realm where even the concepts of existence or non-existence are meaningless. These theories, while speculative, fuel the imagination and drive theoretical physics into uncharted territory. Each model offers a different lens through which to interpret our origins, some rooted in quantum fluctuations, others in higher dimensional geometries, or timeless information states. None are yet proven, but each takes us one step closer to confronting the ultimate mystery, the origin of everything.